Hope you guys are able to hear me.
Yes.
Yeah, sorry, let me share my screen. It is having some problem. Yeah, now you should be able to see my screen. So we stopped yesterday while discussing joins. So we covered the theoretical part of joins. Hope you guys are able to see my screen as well. Can anyone confirm?
Yes, Aaron.
Yeah. So we covered the theoretical part of joins in yesterday's class. So now we're trying to show the exact thing in practicals via MySQL Workbench. Okay, so let us do that. So this is what we covered yesterday. So we have customers table and orders table. So which contains ID, name, age, address, salary, and these columns. We have done inner join and we see the result output. So we also covered how these results are getting populated one by one. Okay, so now we are trying to see the same results in a practical session, how it is going to work out. Okay, let us move on to Workbench, MySQL Workbench. So I already created the tables. Here you see customers table. So just for your understanding, I am just select star from customers. So please don't confuse. This is a different version, like old version of MySQL Workbench. Like the look and feel is different to what you are using right now. Okay. So if you see, there are 7 records like our table, and then we have orders table. Select. Yeah. Now we're doing a inner join using this query. So while doing inner join, we need to first write select and what are the columns from the respective tables, and then from and the tables, and in middle we need to provide inner join or just join is enough. So if we don't provide inner also, by just providing join, it understands it is a inner join by default. Okay. So let me do just join on IDs. I mean, from customers table, we are joining with ID, and from orders table, we are joining with customer ID. Okay. So when I select this and run, what happens is only the selected portion will get run rather than the entire statements, all the statements. I'm running this and we see, as expected, we we got 4 records or 4 rows, okay, which are sorry, 2 customer ID 2, 3, 3, and then 4. 3, 3, and 4 with orders 102 and so here I need to provide not 102, it's 100, right? I think manually I would have done error because we have two rows, right? Yeah, now it is good. Yeah. So inner join, basically what it joins is from the customers and orders, it selects the intersected part or the common part among the customers and orders for the mapping columns. In this case, the IDs, customer ID and the ID. Okay, so this is how the output looks like. Yesterday I would have shown this, but I just want to show you how each row gets populated by itself. Okay, so is that clear? The inner join part? Or any questions on this? Yes or no? Yeah, okay. Yeah, hope it is clear to all. Yeah. So moving on to the left join part. Again, we are dealing with the same tables, customers and orders. So this time we are using a left join instead of inner join. That is the only difference. So see, I will try to run the same query with inner join, like with using this inner keyword, the same results you will get with the same results. Now what I'm doing, I'm trying to do the left join. While doing left join, the expected outcome is it should fetch all the records from left table and only the matching records from right table. So that is the expectation. So when we do that, the matched records will get populated and the unmatched records will be populated as null values from the right table. Okay. So while correlating to set theory, you can say, so customers, which is the left table, and orders, right table. So if we see, entire portion of customers table will get populated and the common part of orders table is also getting populated. Okay. So I'm running this query, left join. See, and the expected outcome is, see, we have these 4 records in middle and 3 null values below and 1 null value above. Okay, with the respective matchings. So we have 4 records middle, 1 null, and sorry. So anyone wants to, like re-explain, like wants re-explanation, or is that clear? So hope it is clear. Yeah. Okay. Yeah, thank you. So similarly, moving on to right join. So just a keyword right. So now the right table takes the priority over the left table, and the expectation is all the records from the right table will get populated, and the respective unmatched records will be populated as nulls. There are no nulls here. That means there are no unmatched records. and all the matched records will be mapped to the right records. Okay. The same thing, don't want to repeat something. So if I run this, you see all the right hand side records got populated and the corresponding left side table also got populated accordingly. There are no nulls here from the left table, and because there are no unmatched records. Okay, that is the reason we didn't see any nulls. Now, moving on to the full outer join part. So where yesterday, I was a bit confused. So I want to clarify more clearly now. So we have customers table and orders table, the same table, and we are doing a full outer join. So by doing full outer join, what did I say? So first put the left outer join results and below the right outer join results. Okay. So I said this and I left, and somebody told me like, what about the duplicates? So there is extra step which I missed is the deduplication. So removing the duplicates from this result set. Okay. So whatever the result set that we are seeing right now is something similar to this. Okay. So which is customers and then below orders, right? So we are seeing both. But when we do deduplication, what happens is we are removing the common part. Okay, because we don't want to repeat this common part twice. Okay, so by doing so, yeah, see, with this, what happens is we are repeating the common part twice. That is the problem here. Okay. So if we remove that common part one time, then what happens is we are removing the duplicates and we are getting the full outer join output. Okay, this is the extra step that we need to add to yesterday's session. Just for your understanding, I made a color coding to make sure what are the duplicates. See, this is a duplicate and the respective color, like 19th and 28th. Okay, let me 19th and 28th records. See, these are the duplicate values. If you see, every value is similar. Every value in 19th record is similar to 20th record. Okay. So that's, these kind of records, we'll call them as duplicates. Similarly, 20th record and 26th record, we have the duplicates. 21st record and 27th record, we have the duplicates. 22nd and 29th, we have the duplicates. Okay. So we are keeping them only once. That's what we have done by deduplication. And we are getting the full outer join output. Okay. So as I mentioned, we don't have full outer join supported by MySQL Workbench. If we run this, what happens is we will get an error. See, we are getting an error. So it is not able to recognize the syntax. So, but it's not the case with all other databases. So you can safely use this by understanding the concept behind this. Okay. So we have a workaround for this to showcase the output of full outer join rather than using this syntax. Okay. So, but theoretically, I hope you are good. I will try to show you how we can achieve the full outer join result using a different approach. Okay. But I want you to theoretically understand this, and I don't expect any questions on this. But if you have any, you can ask me. Hope it is clear. My screen is not clear. Okay. Okay. Is that the problem with? Okay, my screen is not clear, it seems. Is that the problem with only one person, or anybody? Anybody else? Okay, can anybody confirm whether my screen is clear or not?
It's clear, sir.
Okay. I think Deepika, can you try checking your network? Because yeah, it could be a problem from your network side, maybe. Sorry for that. Okay. So now officially we have completed this joins concept, and the one more thing is the cross join. So yesterday I told you, right, why the output of cross join also we'll see, and then the use case also we'll try to cover that. For now, I am using the customers and orders table again just to show you the output. Okay, how the cross join looks like. So cross join, it doesn't rely on any keyword as such. So if you see, this is a cross join. Remove this comment. So this is a cross join. Select column names from both the tables. Like I want to see all the column names from customers and then comma orders. Okay, and I didn't use any, instead of comma, I mean prior to comma, I used inner join or something like that in the earlier queries. Okay, but now I'm using comma, just comma, that's it. So if I run this, what happens is, as you mentioned yesterday, 7 4s are 28. We have 7 records and 4 from orders table. So 7 into 4, which is equal to 28. So we are getting 28 records. See the last one, 28 rows returned. So that too, this is the outcome. So every record from first table will get mapped to every other record in the other table. That is how it will get populated. First, second, third, fourth, something like that. Okay. So somebody asked me the use case of this. So I tried to check in the Google. Obviously, I mean, I didn't find anything, and I checked in the Google to get a use case of cross join. Okay. So then I got to see some use cases, which I would like to share one. For example, there is a table called food items. Food items. There is another table called okay, food juice or something like that. And there is another table called orders. So there are 3 tables here. Food items. In the food items, you can put some rice. Okay. Okay. This is just for understanding. Don't consider it as a real thing or something. Just for understanding, I'm trying to tell this. So fruit juices, apple, and in the orders, I would like to see the combinations. Okay. For example, if somebody ordered food items rice. Okay. It doesn't mean he should only order apple, right? He can order anything. Rice, apple, rice, Mozambique, rice juice, right? So the combination, you can have anything. Somebody might like rice plus apple juice, rice zombie, then rice orange. Do you agree? It depends on the individual, right? So for one food item, they can have multiple combinations from the fruit juices they can pick. Similarly for roti, North Indians prefer roti, right? So not roti and fruit juices. So dal, something. So for getting the combination, okay, in order to get every combination from two different tables, okay, generally we use the cross join. So in orders, I want to capture the combination. For example, in orders table, I want to create and display the combination of food items and fruit juices. So there we can cross join between food items and fruit juices and get the orders table populated accordingly. So hope I try to explain an use case for this. And there are many, but this is one such a simple use case I found, so which is easily understandable because these are known to everyone, right? So is that satisfactory, the use case, or do you feel any? So yeah, yesterday somebody asked me, so the same person, can you clarify on that? Like, can you confirm me? Is that sure? Yeah, cool. Yeah. So yeah, I tried to pick this use case and I want to showcase this. Now moving on to the next concept. So I covered the cross join as well. So we have inner join, left join, right join, full outer join, cross join. And then, so any questions going before moving forward?
No, brother. It's clear.
Yeah, thank you. Sure. Now moving on to set operators. Okay. I mean, we started yesterday our class with joins, and now the second topic is set operators. Okay. Generally, we have commonly used set operators there are two set operators, union and union all. Okay. So there are other set operators as well, but these are the main set operators, union and union all. So let's first see what is union. Okay. Or else let's first see what is union all. Rather than going with union, I would like to show you what is union all. Okay. Where is this? Sorry. Yeah. So before going to union, I would like to show you union all. I'll tell you the reason also. So union all. So yeah, so let us come out of the joins concept, and we are having different tables here. Consider there is a retail store. The store name is ABC. Okay, the store name itself is ABC, and it has two branches. Okay, branch 1 and branch 2. See, branch 1, there is an operator, and he or she is maintaining the table customers _ B1 to record all the customers and their details. So in branch 2, another table is there, another database is there, and they are maintaining it as in a different table, the customer details. So in branch 1, their naming convention is something like this: ID, name, age, address, salary. Okay. In branch 2, the naming convention is something different. See, their intention is same. They want to save the customer ID in branch 1 and branch 2. but they used a different naming convention. Okay, CID, CNAME. So these are the only two differences. If you see, these are the only two differences. Okay, from branch 1 and branch 2. And we don't have any differences in column names, age, address, and salary. Right? And the content also say different, because branch 1 customers may not be present in branch 2, right? So every branch has its own customers records, may or may not be, it could happen. So if you see the first record, both are same. So the first customer ID, I mean Ramesh, or the customer ID 1 is having its details in branch 1 as well as branch 2. So I will highlight those green matched records in green color. See, this is the unmatching record. So if you see, the name is different. Fourth one is also different. Fifth one, yeah, is also same. Yeah, that's it. So yeah, seventh one is also same, right? So out of these 7 records from branch 1, out of these 8 records from branch 2, we have 4 common records in both the branches. So these are the 4 customers. They have their details in branch 1 and branch 2. They are visiting branch 1 as well as branch 2, something like that. So ABC retail store, they want to see the customer details from branch 1 and branch 2 in a single table, for example. Okay. So we have a concept called union set operators, union all. We can use that by using this union all, you can show these results in a single table. Okay, something like this. Select star from first table B1, union all. Okay, you need to use a command called union all. There should not be any semicolon here. I'm repeating, it will throw error because it is not the end of statement, right? So we have continuing the command by writing union all, and also the second table, select star from customer 2. Okay. So, and then we are getting this output, something like this. So this is the output, 7 records from branch 1, because we use first customers underscore B1, right? So obviously we'll get the output as first table, and just below that, the second table records, the 8 records, will get vertically appended. So this is called vertical appending. Okay. So this is one set, and just below that, another set of data, we are appending it in a vertical fashion. Okay. So if you see all the records, like 7 and then 8, so 15 records just got displayed by using this union all. Okay. So the only condition to use this union all is not the only condition, there are conditions. So these are the conditions that should be satisfied to use this union operator between 2 tables. So first condition is number of columns should be same in both result sets. Okay, upon which we are trying to do this union all. Okay, so if you see how many columns are there, I'm talking about the number but not the names. So we have five columns from customers B1, 5 columns from customers B2. So the first condition is satisfied. Now moving on to the second condition, there is another condition. Corresponding data types of columns should be also same. Okay. So for example, if it is ID, we are saving it as a integer. Okay. And in customer ID, we are saving it as a varchar. Then in that case, even if the number of columns is matching, even if the first condition is satisfied, we'll get an error mentioning that the data types mismatch is there and we cannot perform the union operation. Okay. So these are the two conditions that we should take care. So let's move on. Yeah.
1 minute.
Any questions on this?
One doubt, sir. Now you're
Yeah.
telling that data mismatch is there, it will not perform the operation, right? So
Not
will it,
data mismatch,
I mean, the variable
data type.
declaration. Yeah. So will
Yeah.
it throw an error or how it will be taken care?
Yeah. So it will throw an error. First thing is to answer your first question, it will throw an error. So without satisfying the condition 2, obviously this will not work. So in that case, for example, ID and CID, I use the same data type, integer only I used. So in that case, it is satisfied. But to your point, for example, we have a discrepancy here. ID and CID, let us assume ID and CID are different data types. Then in that case, how it will be taken care? So we need to either convert this column to varchar by using the cast functions, right? We have a cast function to convert one data type to another data type. Okay. Or we need to convert this CID column data type to integer data type. Okay. Then, I mean, instead of doing a direct column fetch, we need to cast and fetch the column name. Then in that case, it will assume both are same data types. Okay. So obviously it wants to see the union operator. It wants to see the data types same from both the result sets finally. Okay. It is our duty. I mean, if not, it is our duty to cast them accordingly, and then only you can use that. Okay. Does that answer your question?
Yes, sir, it's fine. Thank you.
Yeah. Okay. So now in this case, we don't have that problem. So the corresponding data types are also taken care while creating the table itself. So I will try to show you the customers B1 and customers B2 tables. So now we have seen it theoretically, right? Just one by one, how they are appending. Now, so we have these customers. Yeah. So before moving to that, I want to show you how the data types are there. What are the data types for this column? So if you see customers B1, ID is integer, varchar, and we have integer. Age is integer. Address also we have varchar and salary integer. And we have customers B2, same integer varchar, age is integer, varchar and 11. If you observe closely, the data type is integer, but inside brackets for customer B2, the value is 6. Okay. So for customers B1, the value is 5. I mean the length. Okay, it doesn't matter because it will just check for the data type, but inside the varchar we have 10 here for name for customers B1. For customers B2 we have 12. Okay. But it doesn't bother about that. Only the data type varchar part only it will take. So before running, I will try running the individual statements. Select star from this B1. We have 7 records. And select star from B2. We have 8 records. And we are doing this union all. So which is, we see up to this 7 records, all these got appended. And just below that, we have these 8 records from the first table. So does anybody got any question how these column names are maintained? Because see, at least one column name should be displayed in the output, right? For example, in customers B1, we have a column names. Customers B2, we have a different column names, right? CID, CNAME. So then SQL will fetch which column names? Any guess?
First tables.
Yeah, first table. Can we select only few names from both the tables? I will come and answer this question. Yeah. Yes, we can do that, provided these conditions are satisfied. So we can do from any result set or any number of columns, provided these 2 conditions are satisfied between the 2 result set. Okay. So yeah, where are we? Now what I'm showing. Yeah, if you see, we have used the customers B1 column and then union all. And just below that, we have used the customers B2, right? So it will use the column names from the customers B1, ID, name. So these are the column names from the first table or the first result set. Okay, this is the first result set. So that is the reason we are seeing ID, name and age. For example, if I use B2 here and then B1 below, we are going to see here CID, CNAME. That is our expectation, right? Let us run this. See, CID, CNAME. Now, if you see the first result set, 8 records will got populated, and below that, we have these 7 records. Okay. So union all, is that clear to you? Any doubts on this? Yeah, hope it is clear. No questions? Okay. Yeah. So I mean, why are we using union? We have a problem with union all because see, if ABC retail store want to see the customer list, it will see 15, right? But it's not the actual count because we are getting the duplicates as well. Okay, so it is just like appending the result set 1 by 1. That's it. So it is not checking for any duplicates, whether duplicates are there, something like that. Okay. So as I mentioned, there are duplicates, 4 duplicates. Okay. So if somebody asks ABC store how many customers, they should not say 7 plus 8, 15, right? Okay, here is my question. How many customers for ABC retail store altogether for branch 1 and branch 2? By seeing these two tables, can anyone tell me how many customers are there for this ABC retail store? Considering the two branches,
11 customers.
11.
Okay.
Okay. Yeah, 11, because we have 8 here, and then I am excluding these 4 common records, only considering the white ones. There are 3. 8 plus 3, 11. That's correct. But we are getting here 15, right? So that's where the union operator comes into picture. In order to remove the duplicates from first result set and second result set, but it will do the appending, vertical appending. It will do the same. It will perform the same operation as like union all, but the only thing it will take care is it will remove the duplicates, as we have observed earlier. Okay, so now upon running this union operator, we are getting 11 records. See, okay, all the conditions are same, everything is same. These two conditions should be satisfied for any set operator. Okay, union all. There are some other operators like except. Okay, the name is except. Okay, so for that also we need to make sure these conditions are satisfied. So let us go and run this union operator. So I'm just removing this union all and then just putting union. Let me do B1 and B2. So if you observe, we have 1, 2, 3, 4, 5, 6, 6, and then 7, 8, 9, 10, 11. So we have 11 records altogether, as like we observed in the Excel sheet. Okay. So yeah, this ends our set operators, union and union all. So there is something like except also. I would like to cover this just for the. I think it is not working here. So in MySQL we have minus is what I'm thinking. Okay, so maybe it is not supported here. Yeah, so it differs from database to database, but yeah, we have common things like union and union all. So just ignore that. Never mind. So we have covered the joins and union set operators as well, theoretically and practically. Exactly, yeah, exactly. So somebody has written, I think the same person who has written this statement yesterday. Yeah, full outer join is nothing but left join plus right join minus inner join. So let us come to this full outer join explanation. See, this is left join and right join. So, and we want to remove the duplicates from left join and right join to get the full outer join output. Okay, so what we can do is we can use the union operator here, right? To get the full outer join output, we need to use union operator between left join and right join. So does that make sense to you? Can you apply that union concept here? Okay. Yeah, maybe, but as I mentioned, we don't have full outer join. I will try to show the full outer join output using the union concept. Okay. So we have left join, and then right join. So in between, I am using operator union. So when we do this, what happens is the duplicates from left join and right join will get removed, and only the remaining part will get appended. If I run this, I see 7 records. 1, 2, no, not 7. 1, 2, 3, 4, 5, 6, 7, 8. 3 is repeated twice. So we have 8 records. So which is the same here. Okay. So last 3 records are nulls. First record is null. Nulls. First record is null. So we can explain the full outer join concept using this union operator between left join and right join. Okay. Hope it is clear. Any questions? Yeah. Any questions? Or else we can move on to next topics. Or yeah, I think for today we are done with all the topics that needs to be covered. Joins and set operators. So I think we already completed the practical sessions as well. Maybe I will try to share this to you. Share this Excel sheet in the group so that you can recollect and do the same stuff. I'll also paste this query. Any questions from anyone, or we are good? Any response? Chat box. Okay. Yeah, thanks guys. If you have any questions, please ping in the WhatsApp group, or yeah, in the next session also we can cover that. Okay.